Broadcast is now starting. All attendees are in listen-only mode.
Okay, welcome to today's optional webinar for intermediate algebra. This webinar coincides with items that are covered in your book. In this case, it's the Intermediate Algebra 3rd edition from Miller, O'Neill, and Hyde. My name is Eric Ashman, the instructor for this course. Again, this is an optional webinar. It's not required like as it may be in other courses. If you have items that you would like to have covered in the nearby future, let me know and I'll try to get them up as soon as possible. You can email me these or let me know after the webinar would be over. Thank you. Again, this is covering Intermediate Algebra Section 2.1 of the book. The section ID or the subject matter in this case is going to be linear equations in two variables. Again, these webinars cover sections from your intermediate 3rd edition of Miller. This way you can have the information available or in the book as we're running through the various items or chapter problems that will be covered in this webinar. You can always go back and look over those problems if you need be, and generally the ones I do try to pick are going to be the even problems, but sometimes I will pick an odd, and those answers are located in the back area of the book. Some items that you may see up in the upper corner are the following. You may see discussions, important information, objectives, etc. These are the symbols for those items just to let you know a little bit about what the page is about. Again, today we're going to be covering, here's the main objectives. We'll be going over some of the methods of and graphing of linear equations, finding the x and y intercepts, and also determining if an equation is a horizontal or a vertical line. Okay, in earlier chapters, you may have graphed items such as x equal 3, as you see in this first case here. It's just a point on the line, only the point. X greater than 5, essentially an open point at 5, and everything to the right of that, or x is less than or equal to -4. In this instance, it would have been a closed point, and everything going to the left of that would be the answers for the drawings for that particular type of equation. Again, I do go with these lessons. I tend to jump around the book because I get people entering this program or these webinars at different points of when they started the course. I'm not sure if you've seen a coordinate graph before, but this is the typical grid that you would see, again, minus the quadrants listed there. As you see, there's some pluses and minuses in the x and y terms, essentially showing you, what the x value and the y value would be up there as far as if I had a point such as 2, 1, they would be both positive. They'd be in the first quadrant. If I had something like a -2, 1, I'd be in the second quadrant. If I had, say, a -2 and -1, I would be down in the third quadrant in the lower left there. And finally, if I had a +2, a -1, I would be in the fourth quadrant, as you see there. Again, everything in this intersection point here is called the origin. That would be, if I were to have the point listed there, that would be a 0, 0 point where the two x and y axis meet. You may have done a little bit of plotting in the past. You might recall the game of Battleship. This was a limited coordinate system, and in fact, on the left side was letters instead of numbers, and then at the top in this instance, they have the numbers going from the origin out to 10 spaces. Okay, in essence, we will get points in our for our answers, which would be like an X and a Y term, and that would be like having F, like an F4. Okay, in this case, in place F, we'd have an X value, and the other value would be the Y value that we plot secondly. And again, when we start our plotting, we normally start from our origin that I talked about before, which is the center point where the two lines intersect on the original Cartesian graph. Just an example of all this, so supposedly what happens or how will we graph a point such as this one where it was a negative 3, 2. And again, the first term in here of the ordered pair is the x point. That is the values going left or right of the origin. Okay, in this case, it's a negative 3. Therefore, I would be moving 3 spots to the left of the origin. So I go out 1, 2, 3 spots. And then the second value, or after the comma here, is the y term. That's up and down. In this case, it's a positive 2, so we would be going up 2 spots. Thus, as you see here, our point negative 3, 2 would be at this point here that we have graphed. And again, the x-axis is the red line. The y-axis in this instance is the blue line. Okay, solving linear equations. Again, the definition you'll see in the book for the linear equations is some value, in this case, a constant value that's in front of our x term plus some constant value times our y term equals c, like some number. Okay, now if sometimes you may see like just a plain x, there is technically a number there that would be representing 1, but a 1 times x is just x. They don't usually write a 1 in front of it. But at other times, you may see a fraction there, or a different number like 2, 3, 4, what have you. And again, that would be like 4 times whatever the x value is. And again, the same goes for the b term in this equation. They can be anything from whole numbers, negative numbers, or fractions, or even decimals in some instances you may see in the book. Okay, this equation that I'm using here came from page 136 in the book, and we have it's x plus y is equal to negative 8. Okay, where do we start? A lot of times people see these things and they start to freak out, but they're not really as bad as you think. Basically, we're going to pick a value for one of these x or y terms and plug it in and solve for the other term that's left there. Again, I usually tell students the easiest ones to do are like values like zeros, ones, twos, -1, -2, and so forth. There also later on, as you'll find out, if I have a fraction that was in front of my terms, I usually take a value that would cancel out the denominator of that fraction, because it's kind of hard to plot fractional numbers, as you'll see a little bit later on. So in this instance, I'm going to use 0 and -2. I mean, you can use any other values if you wish. The point is of using some of these smaller numbers is we keep the points that we're going to need to draw this line, because I only need 2 sets of 2 points to draw a line. So I only need to do 2. You can use any numbers you wish, but again, I usually try to use some small ones and ones that potentially can cancel out or solve relatively easy. Okay, so if I use 0 in place of x and solve the equation, I have 0 plus y equals -8, which basically leads us to having y is equal to -8. Thus, my answer for this set would be when x is 0, the y value would be -8. Thus, this is one of my points that we're going to be using to graph this line. We will get to that on this next panel, but I still need to get one more point here. In this case, I said I was going to also use -2. So I'm going to plug in -2 this time for the x term. I have -2 plus y is equal to -8. Now, in this case, I have to somehow get the items away from the y term here. And essentially, we have a -2 added to it. I would try to get this -2 to the other side by trying to cancel out this value. So I would add 2 to both sides. Okay, that would make this a 0, and 0 plus y is 0. So that, again, is what our intention is. And then I'd add 2 to -8. So I'm left again with y. And on the other side, I have a -8 and I have a +2, which, +2 is going in toward the positive direction. So therefore, my answer is going to go from a -8 down to a 6 because I'm adding a +2 to that value. Okay, so in this instance, my ordered pair is going to be when the x is -2, the y value is -6 for my point. So in essence, when I go to the next page, I'm going to have 2 points. I'm going to have 0, 8 that I have to find first. And then the second one is going to be a -2, -6. So if I go here, again, we start from the center. And I have 0, which x, y, it didn't go anyway because the first one is 0. I'm going down now because how do I know I'm going down? The y value is negative. So I'm going down to -8. So my first point here, 0, -8, is this one here that has a blue center on it. The second one is -2, -6. Again, we start out from our origin, but this time I have to go, it's a -2 in the x direction, meaning I have to go to the left 2 spots. So therefore, I'll be here at the -2 spot. And again, my y value is -6. So I'll go down, straight down from that all the way to the where y is -6 there, or this point that has the red center is my second point. And finally, what we have to do is construct a line through them because, again, not only are just these points answers, anything that would fall on this line would be answers to that equation. Okay, sometimes later on, you may have be able to take a look at this, especially if you have a graph paper that has the actual grids and stuff. This one really doesn't have all the items, but wherever it would meet in the corners of those grids, they would be answers to this. If you have a graphing calculator, you can actually go up the line and find different answers without having to pop in a number and solve for it. Once I have the initial equation in there and so forth. Okay, so again, taking this line, as you notice in this particular instance, this line is going downhill. Later on, you'll get into what's called the slope formula, and you're going to find potentially that this had a negative slope, and it will always be going downhill. That means that anything that has a positive slope, when you get to that one later in this chapter, will be going upwards. Okay, let's take one that's a little bit more difficult. The last one didn't have any values in front of the x or y terms. In this instance, I have 5x plus 3y equal 15. This is another one from that section. Again, like I said, I like to use very low values like 0s, 1s, and 2s. In this instance, I picked 0 for one of them, but I did 3. Now, there's kind of a reason why I did the 3, because if I can get this somehow equal to 15 and I take it to the other side, it would cancel that other 15 out, and I would get another full point, or a point that wasn't a fraction. Because if I probably put a 2 in here, I'm going to get a fractional value for the y, and thus, again, like I said, it's kind of hard to graph a fractional one. It can be done, but you're kind of estimating because you're kind of in between the squares and so forth. So I use 0, first of all, solving that. We have 5 times 0, which is again 0, plus 3y equal 15. So again, that leaves us 3y equal 15. How do we go from this point? Well, again, how is 3 attached to this y? It's basically a multiplication. So I always call it a process of undoing. So we do the opposite operation to get it away from the variable. So in this case, we would divide 3 to both sides. Therefore, y is equal to 5. So my first order pair would be 0, 5. Okay, the second one, like I said, I took 3. The idea was I was trying to get maybe this x so that it somehow would, with the other value, when I brought it to the other side, it would be a whole number so that it wouldn't get a fraction. Usually I want to try to get it to be 0 if I brought it to the other side. So that's why I picked 3, because again, this will be 15, and in order to get it to the other side, I'd have to subtract 15 from both sides. And that would just leave me with, in this case, the 3y equals 0. And that's the whole intent, because again, when I take and divide away the 3 from the y, 0, divided by any number is always going to be 0. Okay, well, I can't say that you get an undefined when you have 0 divided by a 0. Okay, or you'll get later on, that's a different one. So we'll hold on that for now. So in this instance, when I had 3 for x, my other value for y is 0. So my second ordered pair that's a solution set for this equation is 3, 2. Okay, let's look and go through that process of graphing this one. Okay, again, we said one of the answers was 0 and 5, so 0 from the origin. X didn't go either way because, again, it was 0. But then it's 5 units up because it was a positive 5. So therefore, where the 0, 5 is the blue star this time, up here on the y-axis. Okay, the second one was 3, 2, so we had to go out. Actually, 3, 2, I have this off a little bit. This 3 should be out. It should be up 2 spots. So thus, I'm a little bit off. I should have been a little bit higher here on this slide here, the 2. But again, we would connect the points here. No, actually, I had 3, 0. I think the other one was 3, 0. Excuse me. Is the other line. So 3, 0 is on that point, and then we draw a line through these for our overall solution set. One other thing to keep in mind is sometimes people just put a line without the arrows. These arrows just mean it continues on to infinity, because you're going to get to a point where they're going to ask you, what is the domain and range of the set? And these mean they continue on, in this case, to positive and negative infinity for both the domain and range. And again, they'll be covering that. They may have actually covered a little bit about that in the reviews part in the front of your book. I don't quite recall, but you're going to get into domain and range again later on, also in the other chapters of this particular book. Okay, this time I've picked one that has a fraction in it. And again, like I said, you will get cases where you potentially will get fractions in the equations. And so again, I like to try values. Again, 0 is no problem in this instance because that's going to cancel out with that fraction. However, when I take other numbers, I'll be left with a fraction unless I take something that the denominator would cancel out. So, and again, since this has a 3 in the denominator, I would pick an x value being 3, or I could have gone and taken 6, but when you cancel, you have a 2 left over and you have to multiply that to the 5. I generally, for my second one, I usually just take the denominator as the other point. Okay, so if I put in 0, first of all, in this for the x value, I have 5/3 times 0. That leaves me with 0 plus 1. Therefore, y is equal to 1. So my first point is 0, or first answer, order pair is 0, 1. The second one, like I said, I like to try to get a value that would cancel out this 3, so I'm putting in 3 here. These would, in essence, cancel out, leaving us just the 5 value. So we'd have 5 plus that 1 equals 6. So our other ordered pair would be 3, and our y answer or part would be 6. So my 2 points are 0, 1, and 3, 6. These will be the ones that we will be putting on the graph on the next panel. Okay, and again, 0, 1. Generally, you're starting with the one where you chose the 0 most times. Okay, so 0 up 1 would be my blue dot here, and the second one was 3 up 6 value, and then we sketch our line through those points. So again, our solution set is more than just those 2 points. It's everything that is on that line that goes through those 2 points. Okay, I mean, I could have kept finding fractional answers in between this. Those are all solution sets. Everything up and down this line would be a solution set for that. And I think in one of the exercises, when they have the grid and stuff, you can probably see where we'll cross some of these ones here. It looks like almost like where 1 and 3 is an answer, where 3, 1 is an answer. And you can go back and check that. I backtrack it, and we try to 3 where 3, 1 is. It will give it should be fairly close to that solution. But again, because of these being estimates, they're a little bit harder to place on here because I don't quite have the overall grid. I can be slightly off on these. Okay, but again, these would give you kind of a close estimate of what other solution numbers are, though. Okay, the next thing is what is called finding the x and y intercepts. These are the points where the equations cross the x and y axis. Okay, now this is really not hard. What you're actually going to be doing, in most cases, we are doing part of this with the by putting in the 0, 1 for the x term and putting in and you can substitute the 0 in for the y. We're going to get, one or the other intercept that way. Okay, so when you plug in 0 for the x, you're essentially finding the y-intercept one, and vice versa. When you plug in the 0 for the y value, you're finding essentially the x-intercept for that given equation. So let's give it a try in another equation from this section. In this case, it's 2x minus 5 is equal to 10. Okay, so if we put in 0 for the x, as you see here, 2 times 0 minus 5y equal 10. Well, that basically zeroes out the first part. We get a negative 5y equal 10. And to finish this out, we would have to divide by negative 5 to both sides, leaving us y equal negative 2. So my y-intercept in this case would be at the point 0, negative 2, which essentially be the origin drop at 2 spots. That would be where this line would cross, and we'll see it when we get to the next panel. Okay, doing the same to find the x intercept point, we're going to put a 0 in this time in for the y value. Okay, so in this instance, we have negative 5 times 0, which basically makes that element 0 out. And we're just left with 2x equals our 10. And solving it the rest of the way by dividing, because again, this value in front of the x is multiplied to it, so we would divide 2 on both sides. Again, you have to do the same thing to both sides of the equality. Okay, that's why it is called an equality. We have to do the same amount to both sides to keep our overall equation equal. So you divide 2 to both sides, leaving us x equals 5. Therefore, in this instance, our x-intercept is at 5, 0. Okay, this is where this original line, this 2x minus 5y equal 10, would cross those points on the graph, the Cartesian set. Okay, again, 0, 2. Again, you can see it's on the y line. That's why it is the y-intercept. 0, 2, there's the blue point here. And the other one was 5, 0, going over 5 and not moving up or down. It's right on the x-axis. Those are your intercept points, and connecting if we were to graph the rest of it, going through that, this would be the graph for that overall equation. And here's the intercepts. Wherever they cross this y and x line, those are called the intercepts. Now, sometimes we won't always get an x or y intercept, and you're going to find out shortly when we have what are called horizontal or parallel lines. Okay, sometimes it could be right on the line. If by some chance we had like x equals 0 or y equals 0, it would be right on there. But most times if we had something like x equal 2 or x equal -2, and that was the equation, you're going to find essentially that our linear form is going to be one off of one of these, and it won't cross the particular other axis. And that's what we're covering in this next panel is the horizontal and vertical line equations of the graph. Okay, vertical equations are essentially items where x is equal to some kind of constant, namely ones, twos, threes, etc., or -1, 2, 3. So thus, like something like x equal 5, we'll graph this in a short bit. You know, that's where all the x values across the thing would be 5. All the y's would keep changing, but all the x term stays at 5. So it'd be like having 5, 0, 5, 1, 5, 2, 5, 3, 5, -1, 5, -2, and so forth. And again, all I need is a few of those, but again, the x value is always staying at 5. And then we draw an arrow, drawing a line through all those points. You'd only need, again, 2 of them. So what about the horizontal line equation? Well, again, that would be just the opposite. Y equals whatever. Okay, in this case, if again y equals some kind of constant. In this case, I chose y equal -3 because I've been using mostly positive values. This particular instance, I'm going to take a negative as part of our equation. Okay, so let's look at the graph of these equations on the next page. Okay, where x is equal to 5, and notice I also made these red and blue to show essentially which one represents which on our graph. So x equal 5, well, again, 5, 0, 5, 1, 5, 2, could be 5, 10, 5, -10, all those items. So therefore, this is again, a vertical line. Horizontal, think about the horizon. It's level, like with the lay of the land. Verticals up and down from that. So again, our vertical line in this case is that x equal 5. Okay, where is y equal to -3? Well, we could pick different points, but we always keep the y value of our order pair being -3. So 0, -3, could have 4, -3, -4, -3, and so forth. All those values would be here on this blue line that is constructed. And you'll notice, again, it's basically parallel with the x-axis there. Okay, so therefore, here's our horizontal line. And again, horizontal lines, how do we know it is? It has a y equal to some constant value, as we had stated on prior screens. What about word problems that would use these? Okay, you do see these are more common than most, because a lot of times they use these types of items to find like minimum values that they need to sell in order to break even and so forth. And if you have business courses, you'll be using it there. You may also have it in other courses where you have to figure out the minimum or the maximum in some cases that we can allow, like say if I was in vet tech or the like, the maximum you could have for a certain weight of an animal, because you don't want to overdose, or you also don't want to underdose the animals. Again, and it's kind of difficult because sometimes they have a little bit of a leeway on how much you can give per pound of the animal. Okay, in this case, we're going to do it based on a sales salary. Okay, this individual gets a base salary of $10,000 a year, plus he gets $5,000 commission on the total sales for the year. Okay, so in other words, they have a fixed amount that they get paid, plus this other one is called a variable. It's based on how much he sells. He gets 5% more based on those sales. So again, if I was to write this equation, we have a fixed cost would be 10,000. Okay, the other one's a variable. It's based on the number of sales. So we'd let the sales be X. He gets 0.5%. 5% is 0.05. So we have 0.5 times or 0.05 times X, because again, 5% is like 5 over 100, and if you divided that, you would get a decimal 0.05. Okay, so our equation then for this particular problem would be y equals 10,000 plus 0.05x. So if they asked us how much would this person make if he had a sales of $500,000 or 500,000 here for the year, okay, and what would they make if they had, say, 300,000? So we're going to find out how much they make with two different amounts of sales for the given year. So at 500,000, we're going to plug it in for the X value. We would take that value times the 0.05, and in this instance, you get 25,000. You can use your calculator. You can do it by hand, either or. And you would have to add that to the fixed amount that they make of 10,000. So in this case, for that given year, this person would earn $35,000 for the year with that many sales. If the person sold only $300,000, again, the process is still the same. You're plugging it in for the X value, and you're multiplying it by the 5% and adding that to our constant fixed salary of 10,000. In this instance, for 300,000, you would get this variable amount of $15,000 plus the initial fixed cost or fixed salary of 10,000. So in this instance, the worker would earn 25,000. And what happens if they're a million? Well, again, you take 0.5 times a million, and in this case, you get like 50,000 for that particular one, plus 10. He'd earn $60,000 in that case if you had $1 million in sales. Okay, now they asked in this one, again, I grabbed this from the book, and this was number 45 in the practice section. They had asked about the y-intercept and what it might mean in this case. Okay, well, again, generally, the y-intercept, again, or the intercepts are generally the minimum amount of sales that can occur in most cases. And the second thing they asked in this one, why is it reasonable to use negative values for X in this problem? Okay, well, let's take care of the first again. And the minimum, or the why don't they have a negative value for X? Because you don't have negative sales. You either have zero sales or you have positive sales. So therefore, if this person didn't sell a thing, okay, he would get 10,000. Now he probably wouldn't be employed long because they'd be kind of upset that he didn't make any sales and they're paying him 10,000 to do nothing. Okay, and I mean that's the whole point of the incentive 5%, is to get out there and sell more, because again, that's where you start to really make the money. Again, the y-intercept here, you'll note we'll find when we get to the next page. Now the problem with this is I can't show it, but our graph would be starting up at the fixed cost, or at the 10,000 units. So this first blue dot would in actuality represent the $10,000 minimum cost. Now can't remember if this has it in the back. I think it has the graph in the back of the book. That you'll see that point there is at 10,000. Okay, that's where the fixed cost starts, and then it goes up. Everything from this point going up from there is what you would have earned at different sales levels. Okay, you'll notice it doesn't continue to the left because, again, we can't have negative sales. You either have zero sales, which gives you the bare minimum, which is the 10,000, or we have positive sales up to infinity. So they can realistically, if they have thousands or tens of millions of dollars, they can do very well on salary wise if that were the case. Okay, so again, the y-intercept point is our minimum level of salary, and in this case, if they had zero sales. Okay, at this time, this is relatively a short lesson, but because again, it's one of my first of the series for this book. But I do leave at the end of most webinars times for questions. And generally, if you have questions that you think of at a further time, you can just email me through the Contact Us section, ask a question area. In there, you just plug in contacting instructor, and that will bring up a little FAQ letter, but it'll tell you if you go to that letter that now you'll see a tab come up that wasn't there before of contacting this school. If you click that, that creates an email. And since you logged in your web page, your other information is there, because many times people sometimes, especially if they were a student in prior years, were using just the general email address. Well, we wouldn't know who you were or where you're at without those student numbers. This way, we get that with this email by going through that method. Okay, at this particular time, I'm going to be ending this webinar, but if in the future any student has questions or looking to have a certain one done right away, they can let me know, and I can try to get that put together so that I can try to have it available as soon as possible. Generally, I run these webinars approximately every other week, depending on what's happening, because again, sometimes there are some other projects, etc., I have to do that I don't quite get to that point. In fact, I really didn't get to webinars for this course until recently now. In fact, this is the first one up for this new book. Thank you for the webinar today. I hope to see you again in the future.